Welcome to another episode of Aspire Technology Partners Data Streams. I'm Christian Chavez. I'm the Data Center Cloud Solutions Architect at Aspire. We are following up on our previous videocast that we did. Our theme is modernizing data centers and realizing cloud benefits. How do we get to the cloud by modernizing data center? With me today, I have Chris Kudlick he's our PSS from Cisco. Chris, introduce yourself. Say hi to everybody.
Hey everyone, my name is Chris Kudlick, coming here from Newark, Delaware, and I am a data center product sales specialist for Cisco Systems. Great to meet everyone.
Excellent. It's great to have you on. I appreciate you putting some time in for us. So let's just roll right into it. I mean, I think one of the things that I keep saying, or what I've been saying anyway in the previous video cast that we've been doing, is about data center modernization. And so data center modernization seems to be this term that I keep saying, people throw it around all the time. Let's talk a little bit about data center modernization, what it means in the industry, what it means to some of the clients that you've talked to,
Yep.
because I think we've gone from a few transitions to what is now data center modernization. Like, we talked about transformation, and we've gotten to this point. So give us a little bit of maybe historical, whatever it is that you're seeing or what it means to you and what you're seeing.
Absolutely. So, when I first came into the industry, which was back in the late 90s, actually, which a long time ago, back in those days with the x86 server, and everybody really remembers these days where we had the, single socket Intel, processor. We might have had 2 or 4 gig of RAM and local hard drives, local 1 gig, if you were lucky, sometimes 100 meg NICs coming out of every single server. Right. And for every single operating system and every single application, we used to have one server. And so you can imagine that, a customer today that has, I don't know, 1,000, 2,000 virtual machines or even applications, usually equated to 2 or 4,000 physical, servers back in those days. And so then really what came about was the idea of a SAN, or a storage area network. Because part of it is that when you're running a lot of local storage, well, it's hard to kind of replicate, not to mention backup or even replicate a lot of that data. A lot of us had tape drives that were connected directly into the server where we just backed up to tape every single night. And of course, it became a nightmare. A lot of tapes would fail and you had to store them off site, and recovering was it was almost unavailable. They're basically incapable of doing it. So the idea of the SAN came out, right, where all the data really came onto a SAN, and you were able to, carve everything into LUNs with block storage. People were connecting it using iSCSI. Back in those days, it was mainly fiber channel, through a fiber channel type of switch, just because that was the offering that gave the best resiliency as well as the best bandwidth. iSCSI at 1 gig was still a little iffy, right? Running on that TCP/IP stack, where a lot of those switches back in those days didn't have that type of buffering. But I think what really changed the game was the aspect of virtualization, which of course almost all of our customers, are either looking at or have been on for a number of years. And I feel like when virtualization came about, it was, a lot of times when you had one application running on one operating system on one piece of, bare metal server, I would say that on average, we were seeing 3 to 5% of the processor being used, and hardly any of the RAM in certain instances as well. And so when virtualization came around, it was like, well, why don't we try and optimize that? Why don't we try and see if we can squeeze more onto one piece of hardware server, right? And now we're seeing customers with as many as sometimes 125, even some instances like 200, 250 machines, right? In terms of virtual desktops. But, you got to get the picture, right? The CPU is really being utilized very well. And when you think about the aspect of hyper-threading as well as numerous cores and numerous sockets, and, with Intel and AMD growing as well, we're able to squeeze more and more onto a smaller hardware footprint, which less power, less cooling, as well as, less to manage, right? And then, of course, then we started taking it even a step further than that, right? So virtualization came around, and then came containerization, being able to actually, virtualize the applications now, and with microservices and containers like Docker, et cetera. And that has brought about a whole nother ball game where now you can actually just run these in either the cloud, or you can run them on prem, or it doesn't even need to be on a virtual machine. It can be on a bare metal machine, but you can have thousands or millions of these containers sitting around there, and it causes for some really good development advantages, being able to develop on these microservices as well as these containers to push everything up. And so yeah, we're at a really really pivotal time from what I'm seeing with a lot of our customers, where everything that's most customers out there, especially because past 2 years we've been in lockdown with the COVID,
Yeah,
and
yeah,
ultimately when we think about that, the customers that had a digital modernization project in play or had a vision of where they were going to go with that are the ones that succeeded, during this time, where they had something that they could offer electronically. They had some sort of website that they could do commerce with. They had ways of being able to reach out to their customer base, to their employees, and being able to switch that into a digital realm from where we were before was imperative. And we started seeing a lot of our customers succeeding in that. However, we are starting to see some customers getting some of that, some of the cost issues, right? It's not free to run things out in the
yeah,
public cloud. And, but now that things are starting to balance out where, we're starting to be able to go back into the office a little bit more, customers are starting to be able to take a breather, right? Like, okay, I know that at this point in time, we're starting to get back into the normalcy of a hybrid, workplace. Where is the best area to run these applications? Is it on prem? Is it in the cloud? Is it both? Having part of it on prem, part of it in the cloud. Do I go to a colo? Do I keep the data center in my, in my corporate office that I'm leasing? And ultimately, we are starting to see all of our customers are really going toward the hybrid environment. Everybody's going to need stuff on prem and everybody's going to need stuff in the cloud. And it's just really the reality that we're seeing from everybody.
yeah. I think, and I don't miss those bare metal restores back in the day when everything was on single server.
Yeah.
That was a nightmare. And like you had mentioned, virtualization comes in. Backups are being leveraged for now the virtual machines where you can kind of just pop one back on. It made life easier. But yeah, I do remember those bare metal restores. But so the shift, right? I think what you'd mentioned is the shift was ultimately trying to compress all the resources, right? Those that weren't being utilized, obviously, we had leftover resources. So how do we get utilization out of that resource? And you're right, virtualization came in to be, but it was still an infrastructure change, right?
Yeah.
We weren't really, even though the applications, I'm an application guy, and I like talking about that side of the industry, but applications drove that, but it really wasn't because we were still monolithic applications at the time, right?
Yeah.
So we had to run these big things that just churned away on physical boxes. Then we tried to fit them into virtualization. So even though they were a driver, they weren't a conversation, right? It was how do we get the most out of our resources? So we started, virtualization, we compressing. But yeah, you're right. We're now in the age of where we're building out these modular applications as opposed to something monolithic. So now we're spreading things across a lot of different areas, whether that's cloud based or on prem infrastructure.
Yeah.
Um, but with that being said, one of the things that we started moving to not only just to virtualization and moving to the cloud, but bringing what is a server today, right? Well, you had mentioned it. We had servers and we had storage.
Yeah.
So the storage piece was, we talk about converged a lot, converged infrastructure, things that are kind of made it together really well. When it comes to server and storage, we have networking pieces that sit on top of that, and we have this great environment that we can create. But now we still have separate things that we need to manage,
Hmm.
right? So
Yeah.
we're I know database admins, I know storage admins, I know networking admins and server admins, right? And each one took care of their own piece.
Yeah.
And so we were kind of siloed where we have our storage admin, server admin, at least for this conversation. Um, and there was a constant, well, I need this, I need that. So the service level between IT was, I need something from server and I need something from storage. So it was two separate places I need to go to, right?
Yep.
And now virtualization helped us out a lot in that area, but it was still kind of separate, right?
Yeah.
Um, come in hyper converged, right? So now we tried to change the game.
Exactly.
We've got servers, we've got storage, we got two management aspects. We have virtualization, but how do we now get this all into one, right? So now we have, like I mentioned, hyper convergence now, where we're taking the storage piece, putting it back into the servers, but making it look like all one. I know you work a lot in that space. I mean, and
Absolutely.
so
Yeah.
tell us about hyperconverged and what that means to the industry, especially when we're thinking about whether we have a cloud migration, whether we have a
Yeah.
cloud strategy, or maybe we're not cloud at all. How does that help us in modernization?
Yep. So great question there, Christian. And so when we're talking about hyperconverged in terms of, in an aspect of what, where we define it at Cisco is network, compute, and storage all in one platform. And part of it, and actually a great word that you had brought up there earlier, was modular, right? Being able to add storage if you need it, being able to add compute if you need it, being able to add network if you need it, being able to, but adding all those independent of each other. And we'll actually, I think that another part of the discussion should be actually around the modularity of the hardware itself, which is, just another piece of that, which not only does software need to be modular, like you were saying, but the hardware that, is coming out is also extremely modular. But in terms of hyperconverged, it's really given the application owners the capability of running their individual application stacks on their own infrastructure, where the application, and as we know, like there's a ton of different applications out there that need a ton of different needs. For instance, you might have a SIM like Splunk, for instance, right, which takes all of the different, all the different event logs and everything, correlates it into just a huge, amount of storage. Well, in terms of that, it might be, that in that instance, the storage might be more, larger than the compute needed. But, you might also have some applications like databases where, depending on how much data is coming into those databases, a lot of times a database has to be extremely compute intensive. Everybody knows with SQL, the more memory you give it, it's going to eat it all up,
It'll
right?
eat it all up. Yep.
and and a lot of our customers still will dedicate a certain amount of processor power and cores and everything to a SQL environment. But in terms of that, being able to design a system where the SQL developers have the capability of having their own hardware stack of storage, compute, and network, which might be different from the security side, which might need a Splunk that might need a lot of storage, maybe a little bit less compute, from maybe some sort of large file system of unstructured data, which there's hardly any compute needed for that, but at the same time you just need terabytes and zettabytes and etc. of cold storage for a lot of that. And hyperconverge really plays well into this type of space because of the fact that, to your point, the hard drives are sitting on the servers, and we're controlling it from the software stack, and being able
Yeah.
to actually allocate where those data bytes are going to be going, whether they're going to these two servers or to these three. Well, you could almost think of it like back in the day, even with SAN environments. A lot of us are used to RAID. RAID 0, RAID 1, RAID 5, RAID 6,
Oh
RAID
my goodness.
10. And
I still have the old calculators.
yeah, exactly. Yeah, I mean, but a lot of times with RAID, it's usually thought of as east to west. If you add a hard drive in, it's just going to expand that RAID set. But with hyperconverged, we've now gotten to the point where if you add hard drives into the system, it's going to grow north south, because of the fact that now you have the capability of just carving that into different data stores, as opposed to it being just dedicated to the RAID set that it was originally done the way that
Mm.
was back in the SAN days. And so, and also the capability of adding compute only nodes, into it, being able to expand off of storage. And I would say that the other piece a lot of our customers are really loving these days is simplified management, right? Being able to manage all of this from a, I mean, I hate saying the word single pane, but it really kind of is. And being able to go into a GUI interface and create a data store, and within a nanosecond, having that data store published to every single server already. I think a lot of us remember back in the day where we had a SAN and we had, servers, and, in the early days of virtualization, you had to go onto the SAN, and you had to create, the LUN, and then you had to partition it, and then you had to give the permissions to it, and then you had to make sure that it was zoned correctly. And then you had to go on to every single server, and then you had to, find that LUN and publish it as a VMFS. And it took a long time. And if you messed up a step in there, it could be, you could bring things down. But typically, it was adding that type of storage in. But now, like within, a couple clicks, I can add 10 terabyte, 100 terabyte in as a data store in hyperconverged. I really
Yeah.
think that that's changed the game in terms of what a lot of our customers are seeing.
Yeah, I think that's key, and I know we'll touch upon that, but it's great that you mentioned that because it leads into, and I just want to quick touch on this piece is, one of the things for data center modernization and getting to cloud, a lot of it is around self service, right?
Yes.
So a lot of it is provisioning aspects, getting things out deployed much faster, whether that's at the infrastructure level or whether that is at the application level, because we want to get, again, going back to the very top tier. I always say that infrastructure is only cherished by the application,
Yeah.
right? So we can cherish it all we want, but ultimately it's the application that's really realizing the benefits of whatever infrastructure you put underneath it. And I like car analogies. So I'm like, when I go buy a car, I'm buying it for me, right? It's for my experience. And my experience could be comfort, it could be speed, it could be inexpensive, right? And that ultimately drives my decision on what car I'm going to buy. Well, applications don't get to go into and ask for their own resources unless you put tooling in place. But we, as architects, have to understand the application and the things necessary for it to be performant, right?
Right.
So moving back to the aspect of self-service, not only for the infrastructure, but self-service for application deployment, faster speed to market, everything, we know we live by our phones. I'm constantly getting updates on new applications that are being pushed out. New features are being pushed out, and that's what keeps me held on to that, right?
Yeah.
If it's not running good, I'm kind of throwing it away. So and so this is kind of like what drive, and you'd mentioned, right? The administration of infrastructure makes it a lot easier when you build back-end APIs for it, right?
Yeah.
So the API piece is what's really becoming like, so today's, I wanted to talk about server, but we can't, pull away because when it
Yeah.
comes to that down to server, we're talking CPU, RAM, disk, right? Your traditional table stakes, it's inside of this box. But at the very top, how are we going to manage that infrastructure? Do we still manage it like we did back in the day? Or do we move to a new modern way of administration? And you had mentioned these dashboards, right? Or a portal that I can log into
Yeah.
for hyperconverge where everything's as one. That's all really being driven by APIs, right? And APIs now are like the thing to do or to work with to build infrastructure. So
Yeah.
real quick on the API piece, I kind of want to touch that. The APIs are being pushed everywhere nowadays, not only for applications like they traditionally were, but also for infrastructure. We know about tooling sets like Terraform, Ansible. They all help us in these to be able to roll these things out. From a from a modernization perspective, the APIs that you're working with or you're seeing out in the industry today, how is that impacting my journey to cloud? Because again, we're still talking data center modernization on prem.
Yeah.
How does that get me ready for a cloud migration or cloud strategy?
Yep. So great question there again, Christian. So first thing I want to do is actually level set on what an API is, right? And so for any listeners out there that don't know or are questioning what an API is, an API is a menu when you really think about it. And when you think about an API, if you go into a restaurant and let's say you have you're sitting down with your family or your friends or your coworkers at a table, and the waiter or waitress comes over and gives you the menu. Well, the menu is the API, and so you're the consumer. and whatever you want off the menu. In this case, if I want bacon and eggs, right, or if I want a ham sandwich or something like that, that's what I would typically order at a restaurant. But if
Yeah.
I want, Christian's name, if I want Christian's address, if I want, Christian's phone number, if I want, to know his, certifications, all that kind of stuff, then ultimately by contacting the API says, all right, this is the menu of information that you can abstract from the data that I have, right? And so then you could think of, once you call, then the API, is like the waiter or waitress, goes back, gets your food, brings it to you, right? And that's really what an API is. And in terms of what we're seeing with these APIs is that all of the plugins with a lot of our software solutions are using these, especially in the as a service realm. And so, for instance, at Cisco, we have plenty of as a service type of deployments now. On the networking side, I'm sure you've seen Meraki, right? It's the claim to fame from Meraki is that you have your equipment on prem, but it's all managed from an as a service. And by doing that, you can have an app on your phone. You can go to the Meraki dashboard, click everything, just punch in everything, and it automatically pushes down to it, and it creates a great user experience with being able to contact TAC, which is Cisco support, or whichever support environments are out there. But we're starting to see the server and the application, and even into the application optimization side of things, starting to take advantage of a lot of these APIs now, such as Intersight, with the capability of using some of those plugins like workload optimization, and being able to tap in and seeing whether or not my virtual machine needs more resources, or whether it's using too much, and being able to do calculations like, is this application actually a cloud candidate? Being able to see whether or not this application should be moved out to AWS, or maybe it might run better and cost less if it runs in Azure, or might cost less and run much better if it stayed on prem on Hyperflex, or on some sort of converged infrastructure. But knowing that based off of a series of metrics that are obtained through these APIs is critical. A lot of our customers out there have over 1,000 applications, right? Easily a ton of them have 1,000 applications, and that goes up exponentially when we discuss containers, because a grouping of containers and microservices could be part of an application, in a certain
Yeah.
instance. And it gets to the point where a human being can't actually make all of those decisions rationally, because there's just too much information. And we start relying on machines and basically being able to determine, based off of certain metrics, based off of, certain aspects of the way that the application was written, based off of the underlying operating system, where this application should be living, where it should be replicating to, how it should be being backed up, and utilizing all of this information in real time and actually having that automate is a huge part of this. And that's really where we're seeing these APIs roll.
Yeah, definitely automation is really coming into the fold pretty heavily, and I know all the vendors are pretty much either tying with tools that are already out in the industry for deployment. I mentioned Terraform, Ansible, some of these tools that are out there to be able to bring infrastructure up in an automated way,
Yeah,
even to the point where developers can now, make that part of their flow, right? So their flow actually creates the infrastructure, rather than having to put in a ticket and wait for somebody to actually deploy virtual machines or any of that infrastructure. It's just an automated piece.
exactly.
Again, getting your applications faster to the market is key, right? And I think that a lot of that is driving it. And as I mentioned earlier, we're really dealing with applications everywhere, and having that drive the industry is, to me, is the key piece, which is why I like that area, right? That area I think is very intriguing because,
Oh, absolutely.
ultimately at the end of the day, that's what's really driving, a lot of infrastructure today and how we do things with infrastructure.
Absolutely. Yeah. And, another piece of that is performance management of the application all the way through as well. We have customers that, depend on the applications now. I mean, I remember at one point in time, it was, when the internet first, was starting to come about and email was out. This was probably even before the days of texts, right? We had pagers and different things, but, the internet was kind of like it was in its infancy for the most part, but now internet is so critical. Like it's actually, thought about these days as, when people think of what you need in order to live, right? Well, you need food and water, shelter and clothing. Well, the next one after that's usually internet. And, when we're thinking about, our customers, they depend on their internet site, in order to drive business in, or to be, a useful tool for any of their customers or their employees to interact with their company, as a whole. And so, because of these applications becoming dependent, and so dependent, of our customers, this performance management is almost becoming a huge topic as well. You'll hear about it at APM, out there, and being able to see a lot of that real time data, um, as an application is out there, of whether or not, if it's Black Friday, for instance, and a lot of people are out shopping or they're shopping online, and if I'm a retail shop and I put a coupon out, for instance, and I want to
Hmm.
see whether or not that coupon is actually having an effect on customers actually buying that product between the hours of 9 and 10 a.m. on Black Friday, you could start seeing those metrics real time, starting to see if you need to spin up more containers or applications, seeing if there's a lull where you might be able to spin some down to save some cost, being able to see if there's an issue with line 285 of your Java code that might be integrated in, if you're, from the shopping cart container of the application, being
Hmm.
able to pinpoint that so that you can fix it right away. This is like, I mean, it's becoming so critical for a ton of our customers, if not all.
Yeah, and that's why, again, just kind of circling back, that's why it's important for infrastructure. We take a look at servers and storage today as commodities, and they are. I mean, I guess you can kind of look at them at the very low level, but at the end of the day, it's still a necessity
Yeah,
to drive it, right. So whether you're building on prem, whether you're moving out to the cloud, obviously cloud gives you flexibility, and we'll talk about that. But the on-prem piece, right, we have to make sure that we have that infrastructure, and getting it up and running in an automated way is ultimately the modernization aspect of it, of that process, right. Is the modernization is being able to get to things faster, get things deployed faster, and whether that's infrastructure or whether that's application.
absolutely,
But
Christian.
yeah.
Yeah, and part of that is the modularity of the hardware itself too. And
Yeah.
so, as the chip makers keep coming out with more cores, right? As memory keeps expanding, right? We're already up to the 256 gig chips, and probably even into the 512 and 1 terabyte soon. We're already able to pump 100 gig, 400 gig in some instances out of the server. Um, as well as the need for these GPUs, right, or graphics processing units, which
Hmm.
not only are for graphics acceleration, but you could think of those as being workhorses for a lot of artificial intelligence and machine learning and genome mapping and Bitcoin mining, on a lot of those different high intensive applications. But powering and cooling and being able to keep that hardware resilient is requiring modularity. And by modularity, I mean, if I need a bigger power supply, I just take out the old one and put a new one in. If I
Yeah.
need faster fans, I just take out the old ones, I put the new one in. If I need a bigger backplane, I just take the old backplane out and I put the new backplane in. um, and we're starting to see that in this industry around not only switching, because we have that capability for a number of years now with the Nexus 7s and all the way through the Nexus 9s now, where the fabric modules are, you can rip out your backplane, put a new one in. It's back planeless, I guess you could say. But we're starting to see that with the server infrastructure now too, and our blade chassis and capability of actually taking out the backplane and putting a new backplane in if you need it to be faster. Being
Mm,
able to share resources all in the same containment so that power, cooling, and everything is kept in check. But at the same time, as Intel comes out with their eighth, ninth, 10th, et cetera generation processors, AMD is going to be continuing to offer competing products with Intel. Nvidia's out there creating some of the greatest GPUs you could ever imagine,
yeah.
but being able to keep up with that and being able to have a system that is compatible, not just now, but 5, 10, 15 years into the future is really, a big part of that hardware modularity on-prem for that infrastructure too.
Yeah, agreed. It's getting pretty good. Thank you for joining me and Chris Kudlick for part 1 of the Aspire Data Streams podcast. Don't forget to join us for part 2.